Hello. Hi, everyone. My name is Anastasia, and I'm from Fabric Ventures. We're co-organizing this meetup with the Polkadot guys. To the ones of you who don't know about Fabric, we're investing in decentralized data networks. Polkadot is one of our investments, and which we're very happy and proud of. If you'd like to join any of our events, meetups, become part of the talent network, and sort of do stuff with some of our portfolio projects, please check out our website, Twitter. There's always really fun stuff going on. And yeah, I'd love to pass it over to the guys at Polkadot to kick it off. Yeah.
Hi guys, welcome. So this is my first time presenting in London. I did live here for 3 years, so it's almost like home turf, despite the accent. So we're from the Web3 Foundation. Myself, Adrian sitting in the front row, and then we have Alistair at the back. So Polkadot is a decentralized protocol. I'm going to tell you more about that, obviously. But we don't work at Polkadot. Polkadot's just this protocol. We actually work at the Web3 Foundation. That's where our employment contracts are with. So just to help clear that up, we're also not parity, which I'll go into a little bit. So this cool graphic is a graphic. It's not actually our logo. Everyone thinks it's our logo. It wasn't intended to be. It just came that by accident. But it does look kind of cool. So while you're all mesmerized, hopefully hypnotized, I'm going to try and sell the product while you're hypnotized. No, it's not that bad. Basically, I'm going to give you some of the problems in blockchain and then say why I think Polkadot solves it. But first, I'll talk a little bit about the Web3 Foundation. Okay, this is me, Edward Thomson. This is my Twitter handle and my email address. If you have any questions afterwards, feel free to email me. I'm pretty sure you're not going to write this down now, so I'm going to have it again at the end. I learned that one from experience. Web3 Foundation, we are a Swiss foundation. We are headquartered in Zug, so Crypto Valley. We collected the money with which to build Polkadot. So we are this legal entity that collected the money, and now we're paying Parity Technologies to build it. But we have this very grand vision of a decentralized web. So that's where we want to try and get to with our overall view of the world. But before we get there, we want to make sure we can get Polkadot built, because that's part of our vision. Gavin Wood, you probably know him. He is our president, so he's the president of the Web3 Foundation and was a co-founder of Ethereum, and I believe he did most of the coding for the first proof of concept of Ethereum. So he probably doesn't need an introduction. I want to say that we're hiring. These jobs are in Zug, preferentially. We might consider remote, but preferentially in Zug. So social media manager, we have a bunch of social media channels. We have Telegram, we have Reddit, we have Riot, whatever, and we need someone basically to manage it full time. The decentralized algorithms researcher, we kind of have like an open, ongoing positions for anyone who wants to do research, either decentralized algorithms or cryptography or highly related. That's it's kind of open. It's not so fixed. So that'd be great if you're interested. And then eventually community and events. People to help us organize meetups like this, kick off our ambassador program that we really want to do. So a global ambassador program. So that's web3.foundation. No, actually the link has changed. It's now jobs.web3.foundation. Either works. Okay. Oh yes, we have a dev adoption job. Cool. So that's the other one. So yes, we're hiring. And now to actually talk about Polkadot itself. So that's the Web3 Foundation. That's who we are. That's who we're employed by. And we're the ones funding Polkadot. And Polkadot is obviously the topic of tonight's meetup. So, whoa, getting a bit too excited. That was like 5 and 1. Once. Doesn't work. There we go. So this is the contents. It's just text. You're not going to read that. Pretty sure. Don't worry. I'm going to say everything, so forget about it. If anyone's watching this video on catch-up, pause it and they can see what I'm about to say. Basically, I'm going to tell you what Polkadot is. Who's involved? So we're the Web3 Foundation, I just told you. Yay, Web3 Foundation. And also our technology partner, Parity Technologies. mostly based in Berlin, and they're building the first implementation. So neither of us owns Polkadot. It's meant to be a decentralized protocol. But we need someone to build the first implementation. And Parachains are building a Rust implementation, which is the first implementation. And we're going to pay for probably 2 others, maybe 3 other implementations. So we want someone else to do it in Go, probably C++, and then maybe Java. So just something to bear in mind. And there will be money to pay for it, so bear that in mind. So this here is Polkadot in one sentence. If you understand this sentence, then you understand Polkadot. But I don't necessarily expect you to understand this one sentence. It's a bit abstruse. So Polkadot is a heterogeneous multi-chain technology. So let's break that down. What does that mean? So you have more than one chain, many different types of chains. But that's also going to be true of Ethereum once it shards. There won't be just a single chain. But the point of heterogeneous is that not every chain has to be the same. You can have a different state machine. So you have different state machines that act together within the same platform to give you this heterogeneous nature. And when I say a different state machine, they can look very different. Something could be like Zcash or Zcash. I guess in the UK, so it should be Zcash. Or it could be a state machine which looks very much like Ethereum. So they don't have to be the same, but you can still get interoperability. And that's kind of what Polkadot is. And this is the website. So this is Blockchain 101, and I'm sure most of you already know this. This is like, oh my God, this is so basic, like shut up already. Let's pretend this is like Bitcoin or Ethereum or whatever. In the middle, you have a user with their laptop, and they want to send a transaction. So they've got to push out the transaction onto the network, and it's collected by the mining pools. The mining pools collect all the transactions, they collate the transactions, and they form a block. But they don't actually, shall we say, seal the block. They push that out to the miners, which are the other guys. The miners do the proof of work calculation, and essentially they seal the block. And then the miners push that back to the mining pools, and the mining pools push that out to the rest of the network. So, and I'm going to show you why this is relevant going forward and how our architecture is similar. So this is like the architecture perspective of blockchains that already exist, the network architecture. This is basically the same thing again. So you have users, they send out transactions, it's collated by the mining pool. The mining pool collates the transactions, it pushes it out to the miners, and whichever miner is fast enough to basically solve the proof of work, they're the ones that would get the reward. So this is all Blockchain 101. You probably know this already. This is the data structure perspective rather than the network architecture perspective. Again, I expect you kind of all to know this. There's transactions that get hashed, it goes into a block, and so on and so forth. This really is Blockchain 101. Polkadot. So you have a user in the middle who may want to send a transaction, and the transaction goes out to a collator. So kind of like a mining pool. The mining pool, or in this case the collator, collates the transactions. So there's nothing really new here. And then the collators push out those block proposals to what used to be the miners, but is now the validators. And the validators do the calculations to check, and then they vote, basically. They say this block is good, and they sign it with their signature. And if you have 2/3 of signatures agreeing from the validators that this is a good block, then it's a good block, and you get finality. So, I mean, this is basically the same diagram. I've just kind of labeled it differently. So I kind of want to convince you that some of the things that you already know about blockchains is still pretty much true with Polkadot. This diagram is a little bit more complicated, but ultimately it's the same thing. You've got users, collators, and then validators. So the collators here have different colors, and the idea is to try to convince you that the collators don't need to be the same. So the collators can be per parachain. So each of these colors, they're actually going to be like a group of collators. So it's not going to be one machine. It could be 10 machines or 5 machines or 100 machines or whatever. To some extent, it doesn't matter. But each of these collator nodes can be fundamentally different. These are the parachains. They can be heterogeneous. But ultimately, in the validator pool in the middle, they kind of don't care. As long as they have the logic of what your parachain does, they can validate the blocks. But otherwise, more or less the same. So I showed you the data structure perspective before for blockchains. This is kind of the same thing, except my skills with Paint are not very good. So this is the best that I can do. So here we have Parachains, which are labeled para. And that's kind of the part of the topic for tonight, parachains versus smart contracts. So now you get a bit of an idea of what is a parachain. So a parachain is just a blockchain, but we label something specifically as a parachain when it's part of our network. So it doesn't have its own consensus mechanism, but rather it gives that up. It gives up its sovereignty and relies upon the validators within our network to do the consensus. And the validators are the ones who basically control the relay chain. The relay chain basically is absolutely minimal, and it only stores what we call proofs. A proof that the transition from one block to the next block was correct, and basically nothing more. So the kind of the funky arrows on the diagrams, the ones which are going right, that's basically saying I'm going from one block to the next. So time is going this way. With the funky arrows going all over the place, it's kind of to say this is like a transaction. You put a transaction into one block on one particular parachain, the one that you like, but you actually want to say send a transaction to another parachain within our network. And I'm just giving you this kind of concept that that's possible. But I would say don't think about it too hard because the arrows are just for illustration purposes. They're maybe not going to be perfectly exactly like this where it comes into one block and then goes to the next. So don't dwell on that too hard, but the overall concept, the overall vision of what we're trying to do is basically this. And then on the relay chain, you're only storing proofs, basically to prove that good things happened. Basically the same diagram. I copy-pasted, perhaps unsurprisingly. And at the bottom here, I've got another blockchain, which I'm calling Ethereum. And we're basically trying to say, if you have a transaction on Ethereum, you may want to basically push that transaction or push a transaction or some sort of data from Ethereum to Polkadot. And we're basically saying we can also make that work. The details, you can come and ask us about it later, but the idea is that Polkadot is great in and of itself, but at the same time, it's not some isolated network. We do want to have interoperability across as many blockchains as possible. So kind of keep that in mind. So Ethereum is obviously not a parachain, it's outside of Polkadot. It is its own blockchain, it has its own consensus, but it can still talk to our platform. This is basically how Polkadot could look in one slide. So just over a year ago, I was in London. I lived in London. And I went to an Ethereum meetup hosted by Stefan Twell, who was the old COO or CCO of Ethereum. So he does these great Ethereum meetups. He actually has one right now, competing with us. And Gavin Wood came, and Gavin Wood presented in Polkadot. And for me, that was like an eye-opener. Because I hadn't heard of Polkadot. I didn't even read the white paper at that point. I did afterwards. And it was actually this diagram which kind of did it for me, shall we say. So I was sitting in the audience thinking, okay, what's this guy talking about? Polkadot. And then he shows this diagram, like, I guess he's thought about it really hard. Maybe he knows what he's talking about. And then a few months later, I eventually got hired by the Web3 Foundation. So after sitting in the audience in London, and now I'm in Switzerland because of this diagram. That's why it's special. But it's also really complicated, and I may not say too much more about it, but I just wanted to show it because it's a good part of the story. So these are the problems with blockchains. These are 7 main problems. There may be more. You could hassle me and say, but there's also this other one. Okay, great, whatever. These are 7 which I think are pretty important, and I'm going to go through slide by slide, kind of going through what are the problems, what is roughly the current status or status quo, and then what do we want to do in order to solve those problems, and basically try to convince you that Polkadot is solving them, and therefore it's a good thing, and therefore that might be beneficial to whatever it is that you're building. Again, it's a text slide. I'm sorry, it's boring. Don't dwell on it too much. We're gonna push on. So number 1, scalability. On the left-hand side is what we have, and then on the right-hand side, what Polkadot will be. On the left-hand side is, with storage, everyone gets everything. Basically, if you're running a full node, you have to store all of the data for your chain. And on the right-hand side, which I believe will be true whenever Ethereum is going sharding, and what we're doing, which is kind of like a sharding solution, that not everyone will store everything. Everyone gets everything is great from a decentralization point of view, but then it doesn't really scale so well. And at some point, you might want to say, do we really need to store absolutely everything? And if you've got multiple parachains, it becomes kind of unfeasible to store every piece of data across every single chain. You can't really do it. So we're going to make the argument that it's good enough. Second one, within scalability. So me and Alistair had a good talk about this earlier, but I'm going to present it like I did last night, despite what we had our conversation about. So on the left-hand side is a single chain with, let's say, a block time of 12.5 seconds. Doesn't have to be 15. I may have got that wrong. And then on the right-hand side, what we're doing is we're saying, okay, you don't actually need to have just a single chain, but you can have multiple chains. Not every single transaction has to go onto just one chain. You can put it onto whatever chain it is that you're doing for your particular use case. And the block times could be faster. So that seems pretty obvious that if you have multiple chains rather than one, that you have some notion of scaling. And if you have storage, not of every single piece of data whichever comes through the network, but only things which are relevant to what you're doing, you should be reasonably convinced that there will be some amount of scalability. Interoperability. So this is obviously a big one. This is probably the one which people like most whenever we talk about projects like Polkadot or even Cosmos or the other ones that the left-hand side is blockchains in isolation. So they're maybe good at what they do, and it's great that they exist, but in isolation, they're not super useful. So you might have a Zcash down the bottom, or you might have an Ethereum, and if you want to trade between the two, something kind of mundane, you have to go through Coinbase or Binance or whatever. And obviously there's some problems of centralization. There will be DEXs. Obviously we just had Ether Delta. So there are some issues that even if you do run a decentralized exchange, maybe you're still on the hook. So there are some issues, and we hope with Polkadot that we will provide the infrastructure such that someone could run a decentralized exchange on top of Polkadot. Or they could do something more interesting where it's not just a transaction, but it's any piece of data. So an arbitrary piece of data that you want to send from one chain to another. And the one here on the right with the little umbrella, this is an Oracle chain. So you might have some weather data. You want to put your weather data on chain. Or you might have, a news feed, or you might have financial data. So it might be like, Reuters or BBC or Bloomberg or whoever these guys, whatever they want to do. And so you get all of this data, you put it onto a chain, which is great. So you now have news, whatever, on chain. It's an Oracle. People might want to refer to that, but if you're not on that particular chain, then how do you make use of that data? Maybe there should be a nice way that a blockchain with a good use case is able to share its data in an easy way. And so with interoperability, we're basically trying to say is, well, yeah, we can make that happen. The left-hand side is meant to be some private bank chain. So I'm going to have a slide on that later, so don't worry about that too much right now. But the idea is you have a private chain, but you can still get all the benefits of being interoperable. The right-hand side being Polkadot, and basically all the things I said about the left-hand side, all of these features, but able to send data and being able to trust each other is basically the idea. Speed. So this is probably the worst diagram that I have. As I said, my skills in MS Paint are terrible. But on the left-hand side, I'm going to pick on Ethereum. I'm sorry if you're an Ethereum fanboy. I feel you. I love Ethereum, but at the same time, it's inefficient. So if you want to add two numbers together in Ethereum, you have two 256-bit numbers. And I'm basically going to be guaranteeing you that you won't be using anything near that size, like for sure. Like no one does. So there's a lot of inefficiency. The way that the EVM was designed was to make pricing easy. And that made sense, and it still kind of does make sense, but that doesn't mean that every single use case, that every single chain has to be built in the same way as the EVM. And we're kind of saying, since it doesn't, we're going to give you the freedom to do kind of whatever you want. And in doing so, the structure of what we're doing, the architecture is a bit different. And so we're actually saying, well, you know what? You don't really need that. You can get native execution. So that can be a lot faster. And then we also have a WASM sandbox. So you have an either or. Just thinking if I want to dig into more of this, not desperately. Native is the best case, and then WASM is the fallback. WASM is fast enough, but in the best scenario, you do everything natively. And that's the fastest it can be, basically. You don't get faster. So this is probably the biggest selling point of Polkadot. Interoperability is a huge selling point, but I guess this is kind of like, there are other networks out there trying to do interoperability. So what makes Polkadot different? And this is probably the biggest feature which makes it different from the others. So on the left-hand side, you have, well, it doesn't have to be Litecoin or Zcash, that's just the two that I mentioned, but you deploy a blockchain, let's say it's proof of work, and you need to secure that chain. So you decide, okay, I'm going to secure this chain with proof of work, so I need to find some miners. So it's going to be me and my mates down the pub. We're going to have some miners, and we're going to secure this chain. But, you know, even if you're popular with lots of mates, and all of your mates want to mine, how much mining power do you think you're going to have? Probably not that much. I mean, even if you went online and you go to Bitcoin Talk and you ask lots of people to mine your chain, you're probably not going to get that many miners for your chain. There is only so many people who are mining, and therefore if you come along with a new chain, there's a chance you're going to cannibalize some of the population of miners already, which then affects the other networks, and ultimately your chain is not going to be that secure. And there's been plenty of 51% attacks. BBQ coin, I remember, was one quite funny back in 2012. I don't know if you remember it. You can Google BBQ coin, Bitcoin Talk, go back, you can find it, and have a lol. It was kind of funny. I mean, I don't know why would anyone buy BBQ coin? There's no like unique selling point. It was just a copy and paste of Bitcoin with a different name. So yeah, I mean, it got 51% attacked. Lol. That's just not a good situation to be in. You know, if you have this great idea for a new chain, you don't want it to be attacked. And so what we're saying, which you can probably already guess because you've probably already seen the right-hand side, we're saying shared security. So there is a pool of validators already, which already exist within the Polkadot network, which are already providing security. So you don't need to find your mates in the pub who are probably already half drunk when they agreed anyway. You probably can't pay them enough because your token isn't worth anything. Sorry. It was a great idea, but it just, you know, it kind of sucked. Tower Bridge coin, what? No. So if you already have security, you don't need to find your mates in the pub because you've already got security. And so whenever you build a parachain for Polkadot, and when you join it to the network, that part is already covered for you. And none of the other interoperability networks provide that. And I don't think they're aiming to provide that anytime soon, that at least that I know of. If that changes, well, you know, it does. But right now, this is the unique selling point. Privacy, so obviously blockchains are not private. Everyone knows of Ross Ulbricht from the Silk Road. Regardless of whether it's right or wrong, it's just there are issues of privacy. And it's the same with Ethereum, or basically any blockchain. But as you probably know, I'm sure you do, it is possible to have a private side chain with Ethereum. Parity already have this technology, so you can have private transactions on a side chain. And what I'm saying here is, well, yeah, that's also true of Polkadot. You can create a private sidechain with private data. It could be a banking sidechain. Well, it's not really a sidechain, it's a parachain. I don't want to say medical data, because I think that's a really terrible idea. You could do it. I wouldn't recommend it. You shouldn't. But maybe you want to. Basically, it's a private chain. So this is one of the things which can be done within Polkadot. You can still leverage all of the benefits of the Polkadot platform and have your own private blockchain as well. So developability. This is a pretty hard word to say. Last night I totally chewed it. I couldn't say it. This is probably one of Gavin's favorite topics. This is one of his big selling points for Polkadot. Developability is basically making it as easy as possible for you guys to get going. On the left-hand side, you could say, well, it is pretty easy. We can just copy and paste Bitcoin. and get going. I mean, it's 21,000 forks. Even let's say most of those are crap or junk or they never actually got launched or whatever. Even say it's 1,000. 1,000 copies of Bitcoin is still kind of wasteful. And they probably didn't innovate that much. Even if you were to change the hashing algorithm or change the mining algorithm, it's not really innovation. It's not necessarily going to be fit for purpose for what you're actually trying to do. Is it really fit for your use case for business? Probably not. So what we're saying is, okay, what about if we actually gave you a modular framework, a software framework that's highly modular and highly customizable? And that's basically Parity Substrate. And Parity Substrate is a type of Polkadot runtime environment. And it's basically these 3 layers that you get in a box. The bottom layer says libp2p. I messed it up. It should say networking. It's a networking layer. And then we have a consensus layer, and then a WASM interpreter, so a WASM sandbox within which to build your blockchain. And then the top part is the runtime, as Gavin likes to call it. So the runtime is the state machine, or the virtual machine. This is where the magic is. This is where you guys come along with your innovation, and you build it inside the runtime. The bottom part is kind of like the boring part. It's the infrastructure. So there's no point in you recreating that. You might as well leave it to someone else, like Parity. So with Substrate, you get the bottom 3 layers. So you already get consensus inside the box. And it's with Substrate in particular, you have the choice of consensus algorithms. You don't have to connect it to Polkadot, but maybe you should. Obviously, it's a Polkadot talk. So you have this optionality, which we think is obviously a good selling point. And you already get the other stuff. Why bother writing that yourself? Trying and struggling and failing, it's not worth it. But in the top part, this is where you can put all of your business logic and make it tailored to what you actually want to do. And we're basically saying this is the way that probably should be. So Parity have written this, and it's in Rust. And we're just about to have a launch of POC 3, so it's the proof of concept 3 for Polkadot, or it's going to be V1 for Substrate. So Substrate is a Polkadot runtime environment. And I want to say a little bit more, which is that we want to have other implementations. So with Ethereum, you have Parity Ethereum, and you have Geth, and you have a bunch of others. And that makes sense. It really does. And we want to be the same. We want to have a Go implementation. We want to have probably a C++ implementation, and then maybe a Java implementation. And there's kind of 2 main thoughts behind that. One is the network is more robust. So if there's ever some major flaw in Rust, or some major flaw in what Parity have done, then at least you have other clients to sustain the network. So it's good from a resiliency point of view within the network, and then also it allows more developers to get involved. So some developers may not want to work with Rust. They have a great idea, and they want to get going, but they look at Rust and think, oh, this is a bit tough. But maybe if it was in Go, then it'd be a lot easier. And we want that to happen, which means that we have some amount of money that we're willing to pay teams of developers to re-implement what Parity have done in Go or C++. And I'm going to provide you a link later as to how you can find out more. If you are a team who like Go, or if you like C++ or Java and you think this may be of interest, please get in touch. There is money, so you don't have to starve while you make it. We're very serious about funding it. We are putting our money where our mouth is, shall we say. So hopefully I've convinced you that, developability, good one. Web3 Summit in Berlin. So we have this conference that we're going to do annually. We did it in Berlin. This was the inaugural, this was the first one. And the most popular talk by far was Gavin's talk on Substrate, where he was on stage and he had a member of the audience come up on stage and help him to unbox a new MacBook Pro. So taking off all the cellophane, opening up the box, plugging it in, and then downloading Rust, downloading Substrate. And then Gavin said, okay, I'm going to build a blockchain and I'm going to deploy it. And he did it in about 20 minutes. He wrote a module live on stage. You can find the video. It's on YouTube. It's on the web3summit.com website. And he basically proved his thesis of developability. So 20 minutes is pretty quickly to get a blockchain deployed. And part of the reason that that's possible is that you have this modular framework where a lot of the boring stuff is already done for you, and all you have to really do is the top part. And the last problem, and I've kind of ran through these, and I'm sorry if you got lost. Sorry if you can't understand the accent. There's not much I can do. But that said, we think we can at least do something about governance. So even if we can't change Ed's accent, we can at least change governance. So governance in blockchains right now is the left-hand side. And we're pretty critical for obvious reasons. Not everyone agrees with us. Some people think we're kind of crazy, but we think that the current way of governing blockchains is absolutely crazy. And this picture here on the left-hand side, I went to Google and I typed in Renaissance War picture. And that's it. So people fighting and it's messy as hell. And sometimes it's a bit religious. And that's basically what governance in blockchains is about. On the right-hand side is our attempt to convince you that maybe we can do it differently. And we have on-chain governance. So every person who holds tokens will be able to have a say within governance. So if you have something to lose, you have something at stake, then you have this power where you can influence how the network will evolve. And obviously, with great power comes great responsibility. Anyway, don't dwell on that. I messed that up. If you hold tokens, you have the power. So someone can propose make a proposal, it's a referenda, and they can vote on how do we want to change the network. And then ultimately, people who hold tokens will vote to say, is this good or is this bad? And at the moment, you can't do that. At the moment, in let's say, Bitcoin or Ethereum, I don't want to pick them too much, but it's kind of obvious. You could have, say, thousands of followers on Twitter and have 0 Ether in your pocket, but you could still have a huge influence on governance, but you have nothing at risk. And that doesn't really seem the fairest. I mean, why should it be possible? Let's say Lady Gaga started talking about Ether. She has 100 million followers on Twitter. Potentially, she could influence the way that governance is done, but what does she have to lose? Not really that much. And we're saying that doesn't seem right. Not everyone agrees, but we think that is correct. If you have something to lose, then you should be the ones who have the power to change how the network will evolve. And that's kind of the view that we're taking. I think that was the last one. Okay, here's a slide with a summary of the solutions. Again, it's another text slide. Again, it's boring. I don't expect you to read that. I've just told you what it's about. But this is one of these slides. If you're watching on catch up, then you can pause it and you can see all the solutions and enjoy. So collaboration. So collaboration is many things. So we at the Web3 Foundation want to work with other people. Surprise, surprise. collab.web3.foundation. So one of the things we want to collaborate on is meetups. So with this time we're collaborating with Fabric, who are doing a great job. But we want to partner with other people in other cities to be ambassadors to help us run meetups across the world. In the same way that Ethereum is doing it very successfully right now, we want to try and emulate their success as best as we can. And the way that we want people to come to us and offer this help is if you come to this website and register your interest. So if you want to do a meetup, come and speak to us. But then at the same time, Polkadot is not just about meetups, it's more than that. The alternative PRE, which is the Polkadot Runtime Environment implementation, so this is the one where we want it in Go, C++, or Java. This is where there's actually money. Then come to this Colab repo and you'll find the issue and you can note your interest, or you can reach out to me via email, which I'll show you again. So that's there. If you want to build a parachain, if you have this great idea, you want to put your business idea onto a chain, but then connect it to Polkadot, then also come through the Colab repo and come and talk to us. And then finally, building a blockchain is great, but even if you have a blockchain which interoperates with other blockchains, which is also really, really great, as I've hopefully convinced you, you also need wallets, and you need block explorers, node explorers, etc., etc. These are all the things where users can actually interact with your blockchain. And I know with a room of blockchain experts, I don't need to tell you that, but if people want to build this and they want to talk to us, then come to this and note your interest, and that'd be really, really appreciated. So that's collab.web3.foundation. If you want to learn more or basically read everything that I've more or less talked about, it's here without my accent. We have polkadot.network, and then we have our wiki page, which gives you a great overview of Polkadot and how that fits into a wider Web3 tech stack. So Web3 is obviously much, much wider than Polkadot. It goes beyond blockchains. So you might have something like Status, which is a messaging app that sits at the top, that's close to the users. And then you have some infrastructure stuff at the bottom. And then interesting things in between, like IPFS. And we have this diagram which shows you our view of this Web3 tech stack and where the different technologies fit together and where Polkadot fits into this overall view. And hopefully that's to kind of show you where we think things fit and also to convince you that we want to work with other projects, not just blockchain projects, but Web3 in general. And at our conference, the Web3 Summit, we invited projects from all across the tech stack, basically, to come and present. So we had Tezos and Cosmos. Even if you think we're kind of, rivals or whatever, we had people come to speak. I think it's good to have discussion. People from Ethereum, offsets lots of blockchain. We had Juan Bennett from Protocol Labs, so Filecoin and IPFS. We had Matthew Hodgson from Matrix. I don't know if you've ever used the Riot chat channels. So Riot, we use it. It's a bit of a pain in the ass, but it has some many good features. So I don't want to knock it too much, but it's not a blockchain product, but it still fits within this idea of Web3, a decentralized web. So I kind of feel like I can't really just talk about Polkadot without giving you this wider picture of the world and where we fit within it. And this is my contact details, because I know you didn't write it down at the beginning, and right now you probably have some questions. I hope you do. I prefer if you didn't troll me, but you can find me here on Twitter, and if you have good memes, feel free to share them, and then obviously my email address. And we're done, I think. So I guess I will ask if we have okay, plus, yeah. 80,000 screaming fans, yeah, it's the new camp, yeah. Okay, maybe not. You're too kind. The EVM is the EVM, it is what it is. We have almost no opinion on that. It's entirely separate. So we have this WASM sandbox within which to build your state machine.
There isn't a virtual machine per se. You can't deploy smart contracts to the relay chain. The relay chain you can think about like Bitcoin, or like it's essentially custom logic that cannot be modified by user scriptability, which is effectively what the EVM is, right? The EVM allows users to upload their own code in order to change the execution behavior of that state machine. That is not the case with the relay chain. There's no user scriptability on the relay chain. And so if you want to do an upgrade, you sort of, all the validators get together and they deploy a new version of the protocol, and that's how you change the behavior of that state machine.
But with the same software, so with the Substrate software, you can create a relay chain, or you can create a chain which looks completely different. So you can create something which looks like Ethereum, a Turing-complete smart contract chain, which has actually been done. It's called Edgeware. It hasn't been deployed yet, but the software is basically written, and you'll see something from Edgeware pretty soon. And I dare say there'll be other people who want to do something pretty similar. So you have that freedom to build a parachain and connect it to Polkadot, which has smart contracts. So, yeah.
Hi.
Hello.
Hello. A quick question. I was wondering, is the plan to have one relay chain or multiple relay chains?
Great question.
And basically why?
So to begin with, it'll be one relay chain. And the idea is that there will be a number of slots or allocations that will exist for you to have a parachain, and the current proposal is that you will rent a slot for your chain. There are some, it's not fully decided, but let's say you have the slot, you want to rent it for a year, you deploy your chain and it exists there, and you pay, or rather you lock up some deposit for that year while your chain exists. In part that is so that you don't have a stale chain. So if we have a stale chain, we don't really want to be doing a lot of work for a chain which is otherwise crap or noisy. Also, we want good quality chains. And so part of the way to try to ensure that we have good quality chains is to have some notion of rent, although it's probably a deposit. So the actual details of that are not yet fixed. This is kind of the current thinking. But in a later one. So there's probably going to be a point where you've deployed so many parachains that you're kind of getting full up, that the actual relay chain is probably bursting at the seams, so to speak. It can't take any more. We don't exactly know what that will be. We're hoping it could be maybe hundreds or thousands. But at some point we expect to hit a bottleneck, as you get with any scaling problem. And then at that point you have to say, okay, well, what do we do? And so one proposal is that you have a hierarchy. So one of your parachains is itself another relay chain. And then off that relay chain, you have another 100 or 1,000 parachains connected to it, and so on and so forth. So it's basically a hierarchy of relay chains. And we expect at some point that the first relay chain will get full up, shall we say, and then you have a lower tier, and at some point that may also get full up, and then so on and so forth. So yes, there is one relay chain, but there will be one at launch, but that's not to say that there can't be more in the future. Whether someone completely forks Polkadot and does their own thing, such that there's something completely different, some other relay chain, sure, that's probably also possible. Can you interoperate? Yeah, probably you can. I guess we're probably good for questions. Feel free to email me if you have more. Also, if you're passing through Zug, send me an email and maybe we can grab some coffee, sit down, chat about your project. I'm generally happy to do that. If you turn up and knock on the door of our office and I'm not there, then people will probably look at you and wonder what you're doing. So best to email me beforehand and say, hey, I'm coming, do you have some time? Let's sit down and have a coffee. I'm always happy. So that's Zug in Switzerland. And I'm probably out of time, and I'm going to pass on to Adrian.